microphones there.
Thanks, Sue. Welcome everybody to this panel discussion on Northeast hydrogen. The way we're going to run it is we've got 4 5-minute, that's the challenge for the boys here, to stick to 5 minutes, presentations to introduce various aspects of the whole thing, and then we'll throw it open to discussion and we'll see how we get on. So I won't introduce the speakers because you know how it is in these kinds of things. Somebody gives me a piece of paper that they've written about themselves and I read it out to you, so they can tell you themselves. They don't need me to be the man in the middle. So the way we'll run it, the order we'll run in is Dave Robson from Kellas Midstream will talk first, and then Hichem Hakka from the MPI, and then after that Nick Howard over there from Six Engineering, safety and HAZOP and all of that kind of stuff, and then finally Chris Verity from Northern Gas Networks here. So we thought we'd start in the C and then work through to the actual use. Well, at least that's the plan. So I'll hand over to the guys now, and when they've all finished, we'll open it up to discussion.
So I'm Dave Robson from Kellas Midstream. My background, I'm a chemical engineer. I've worked on Teesside all my life. 28 years in the steelworks, managing the energy infrastructure and the power station. Then a few years with an organisation called NEPIC, and then I joined Kellas Midstream. Before I joined Kellas Midstream, I knew very little about them. They've been quite a low-profile organisation. So we're a small, there's 50 of us in total. We have a head office in Aberdeen. We have an office in Wynyard. We own and operate infrastructure through which natural gas flows into the grid. So about 40% of UK gas production comes through our assets. We have challenges with that. You know, we see the world moving to net zero, and we want to help the world move to net zero and be part of that. But we recognise there's a need for energy, and renewables can't provide everything. So we've created a new energies arm. Our first and biggest project is H2 Northeast, which is a blue hydrogen project. So that takes a portion of the natural gas which comes in through the CATS terminal, which we own at Sale Sands. We put that into a SMR. We generate hydrogen and we capture the CO2. The CO2 will go into the net zero Teesside transport and storage network, which you can see on the screen there. The hydrogen, we are targeting energy intensive industries. So we are focused on industrial use of hydrogen. And we have potential customers both on Wilton and north of the river as well. We entered into a JV with SSE Thermal just over a year ago now. So we're both delivering this project. In total, it'll deliver 1 gigawatt of blue hydrogen over 2 phases. And that's about 10% of the UK's target hydrogen production. Or at least it was under the previous government. I'm not too sure if the targets have changed under the current government, but you know, the hydrogen is very much part of the agenda of the previous and current government, so the numbers may change. We'll be part of the East Coast cluster, and one of the key things we want to do is do it at scale. So we want to leverage our assets, leverage our investment potential, and do something at scale. And really, to do something at scale at a reasonable cost now, it has to be blue hydrogen. We're looking at green hydrogen projects, but currently they're more expensive and a smaller scale. We want to create jobs and skills, so we will look to work with local companies, local supply chain as far as we can. That might be limited by the way the government are running the competitions. So we have completed FEED. We completed that just before Christmas. We had partial funding of 8.1 million from the government through the Net Zero Hydrogen Fund. we paid, the rest of that ourselves. And what we're now waiting for is what's called Track 1 expansion. So that's an extension to the Northern Endurance Partnership store to store the additional CO2. So our CATS terminal is there. We're building on the site, so land which is within the existing boundary. It's about 2 to 3 times the size of the existing plant, what we're going to be building in total. We'll be distributing hydrogen north and south of the river. So we'll be going through, we already have a tunnel under the river, which the incoming gas pipeline runs through. We'll be going into Wilton to supply customers over there. We have a customer at Sale Sands, and then we'll tie into East Coast Hydrogen, which Chris will talk about later. So we're heading off into the far left-hand side as you're looking at it to tie into the gas distribution system or the 100% hydrogen distribution system. So this project is interesting. I think we didn't quite realise what we were getting into when we started this. And it's really only as we came and saw the engineering models at the end of the feed, we realised just how big this plant is. It's using Johnson Matthey low carbon hydrogen technology. We have, advantages with it being UK gas going into it, that the carbon intensity of UK produced gas is significantly less than the grid average. There's a lot of imported gas in the grid, which has a higher carbon intensity by virtue of just the way it's transported, but also the way it's produced as well. So that's just an overview, and I'll, answer any question. I'll try and answer any questions later on.
Thank you.
Great, Dave, spot on. Perfect timing as well.
I'm 20 minutes late.
Well, yeah, that wasn't your fault, though, was it? Hichem, over to you.
So yeah, for me, I haven't prepared the slides, so it will be a discussion, quick discussion. My name is Hichem. I'm a group leader on energy and process decarbonization at Materials Processing Institute. My background, I'm a chemical engineer. I have more than 20 years global experience. So worked in Shell, Rolls-Royce, and other institutions. So that's allowed me really to join the dots and understand the kind of the globally what's the impact of the energy, the transition, and for our discussion here, the hydrogen. So the institute is a research. It's an RTO, so research and technology organization. So we had we were in the past part of Tata Steel, British Steel, Corus, and we became independent in 2014. So we still have kind of strong kind of impact on the in the steel industry, but we are also diversifying throughout the foundation industry. For instance, we are part of foundation industry consortium, which joins cement, steel, and other industries or sectors, which allow us to think basically in the systematic or system level way, understanding what the different sectors are doing and allowing us to not duplicate the effort and learn from each other. So we cover usually the mid-tier level. So we work closely with the academic and startups and more kind of well-established companies like Tata Steel, British Steel, and others. So, and we help to mature the technology, so increase the technology TRL level for and making the exposure to get those technology to a demonstration level and adoption ultimately. So we invested quite heavily in the last couple of years on hydrogen. So we have our own storage and hydrogen network, which allow us to distribute the hydrogen in different assets. So we believe definitely that hydrogen will be not the ultimate solution, but will be part of the mix, energy mix. and it will be really important to have this kind of discussion to allow understand or share the knowledge and understand basically the different perspectives, and knowing that for the moment hydrogen is going to uncertainties globally. So I think understanding this from each other and trying to keep the direction and the focus for implementing the hydrogen part of the energy mix. I think that's so. Just for the location, so we are located in Middlesbrough, so on the south bank of the Teesside River, and yeah, I think that's all for me.
Lovely. Thanks, Jim. That's got us up a couple of minutes. Nick.
Okay. Good evening, everybody. I'm Nick Howard. I'm the MD of Six Engineering. I'm a safety engineer, and I hear a lot of talk about hydrogen, and it's mainly about it being in the pipe and so on and so forth. I'm particularly interested in how it can get out of the pipe and what happens if it does get out the pipe. So I'm not particularly interested in slips, trips, and falls. Somebody else can deal with that. I'm particularly interested in explosions and all that really good stuff. It's surprising where hydrogen pops up. It can pop up anywhere, small enough molecule, and that's how it gets out. But in the industries that we deal with as safety engineers, we've dealt with hydrogen in energy from waste through reactions. We've dealt with it in producing fuel, so methanol to gasoline, that kind of thing. We've dealt with it in ammonia systems. It's been around a long time. It's, you know, in industry, it's nothing new. What we concentrate on is helping people understand what the hazards are, and then to determine whether they are doing enough to safeguard against those hazards. And we have a range of hazard study techniques that we employ at varying levels of scrutiny, starting with quite high level stuff about layout of buildings and things like that, and where processes are going to be held and ran, all the way down to looking at leaks from flanges and things like that. So we run through the hazard study process, hazard study 1 to hazard study 6. We also do the SEER assessments, so dangerous substances and explosive atmospheres regs, hazardous area classification, all these things. So we're particularly interested in what happens if this stuff gets out. How bad is it, and are you doing enough about it? Again, you know, these gentlemen are going to talk about it being in the pipeline and things like that. Where, like I say, we're interested in what happens when it gets out, and how you look at that. And we work with a number of industries. What we're finding is that our knowledge and our techniques that we use for sort of major hazard industry stuff is directly applicable to the other stuff that we're doing. So we're working with the foundation industries, so steel research and ceramics research, things like that, and bringing in these new techniques or new to these industries that they've not used before. So we're helping guide them through this all. What we're finding is that it helps with other hazards as well, not just hydrogen. So it can only be beneficial, in my opinion. But there we go. Thank you.
Thanks, Nick. Finally, from an input point of view, over to you, Chris. Look at the end user bit.
Okay. Hi, everybody. Thanks for coming along this evening. My name's Chris Verity. I'm Senior Projects Manager for hydrogen within Northern Gas Networks. I've been with Northern Gas Networks for the last 2.5 years. Prior to that, I've had a career actually delivering oil and gas and power infrastructure here throughout the UK and also in Australia on coal seam gas. One of my first projects was actually here on Teesside at Hartlepool next to the power station at the Greythorpe Dry Dock. In those days, we were building kind of oil and gas rigs, and I worked on the Ravensburn rig, which was one of the last was the last rig to go out of that yard. And now that's coming to the end of its life in the field it went to, and that yard's been used to decommission kind of oil and gas infrastructure. So we're at a kind of pivotal point in the kind of our kind of history of kind of engineering in power, where we're starting to look at new sources of energy or new ways of transmitting energy, and hydrogen in particular. So Northern Gas Networks, we're one of kind of 4 companies that own the gas networks throughout the UK, and that's the distribution networks. We've also got National Gas Transmission that own the transmission network that goes throughout the UK. So we look at everything from the Humber up to the Scottish border and across to the kind of north of Cumbria. And we've got 37,000 kind of kilometres of pipe work in the ground at the moment. Okay. So East Coast Hydrogen is a project that we started probably 3 or 4 years ago now, initially looking at a feasibility study. It's a collaborative project between ourselves, Northern Gas Networks, National Gas, who are doing a project UK-wide, but called Project Union. But the first part of Project Union is here in the northeast. And Cadent are doing a similar exercise, looking at kind of Lincolnshire, kind of South Yorkshire, and down to the North Midlands. And we're looking to connect up the production kind of projects, the major production projects that Dave's kind of an example of in Kellas midstream, but obviously other ones on Teesside and Humber side, and allowing those productions to actually reach kind of industry and allow them to an option for decarbonisation. So this is the kind of high level overall kind of a network. You'll see our network in the north and the one down in the south for that Cadent are looking at. This is the kind of high level view. It's not every bit of that pipeline will kind of happen on day one. So I'll just focus on our kind of area. So this is the map of this area and the East Coast Hydrogen. You'll see those red dots on there. Those are all the highest users of methane at the moment in our area. They're all large industry, so they're making everything: steel, chemicals, building products, food processing kind of companies. They're all taking over 10 gigawatt hours, and you can see they're spread out the region, but obviously a lot on Teesside, all the way down the kind of A1 corridor, lots in West Yorkshire, and on the Humber. So we have got a lot of industry around our area. Teesside obviously is a centre for production that's evolving, but to allow the production to expand on Teesside, we need to get pipelines that go down to West Yorkshire and throughout the area. So the big purple line down the middle is National Gas's feeder 7. That's on the existing feeder, 36-inch line, high pressure 90 bar. We've got 3 of them flowing through this area that used to transmit gas from methane from the North Sea down to the south of England. We don't need all 3 now, so we can move one of them to supply hydrogen and take it from Teesside down to West Yorkshire and across towards the Humber. We might have to put some new lines in to get across to the Humber because the lines there are still being used. But those will take several kind of, I don't know, 10, 13 gigawatts of power. So if you imagine the amount of pylons we'd have to put up to move all that energy from areas like Teesside down to West Yorkshire, it would be huge and probably never happen for a number of decades. The orange lines are existing Northern Gas Network distribution lines that we worked out that we can repurpose to hydrogen, and the pink lines are the new medium pressure kind of PE lines, plastic lines that we would build to reach industry where we haven't got a line that we can repurpose. But as you can see, we can reach most of the industry in the area in Teesside and North Yorkshire. There's one more last one. The final slide is how this might expand further, with the lines going up to Scotland, National Gas repurposing lines going up to Carlisle, and then down the west coast to kind of link up with the similar sort of project INET you might have heard of. It's happening in the northwest. We've got kind of plans to then expand up to Tyneside, which is a bit more difficult to do because the industry is more dispersed there and the pipelines are not as good, but that will be the second stage. So we just completed a pre-feed last year. funded by kind of our existing kind of allowances within our regulatory settlement. And we've now submitted that to Ofgem, who are just reviewing and have given us very positive indications that they'll be kind of giving us the go-ahead to do the feed study and move forward and really start and put some detail and some meat on the bone in that. And the reason that they're supporting East Coast Hydrogen is because of the industry we've got here, the networks we've got here, and all the production that's happening here. And it looks like it's going to be the real focus for hydrogen production in the UK. Okay, thanks very much.
Lovely, thank you. Blimey, there's lots of questions come out of that, but I won't ask all my questions now. Who wants to start? Stuart.
Can I just ask about the legacy pipelines that you've been talking about? How much modifications would they need? In particular, would they all need lining, or can you use the existing infrastructure as is?
Well, that's what the feed study. So,
Can you just let me
Yeah,
repeat the question for the microphone? Stuart's asking whether legacy pipelines can be used or whether they would need lining. If you can all make sure you speak up, please, because we're aiming for this microphone.
I'll give this microphone up to the people asking the questions, but you can answer that one.
Yeah, go on, you need to go first.
yeah, okay. So, in principle, there's no reason why we can't use all those pipelines. The majority of them, because we're not talking about distribution lines, the ones in the streets, which might be cast iron or these are all 10-mile steel pipelines. So they can, in theory, all be used. The challenge we've got is a lot of them are old and getting information about them to things, so we have to do various tests and analysis to demonstrate that we can use them as they stand. Some of the above ground installations will have components that will need to be changed, etc. But the pipelines themselves, where most of the disruption would be if we had to replace them, and the cost are fine to use as they are. But we might have to go down and do various inspections, radiography things to demonstrate the kind of integrity of those lines.
They're all welded.
All these ones are welded.
Right.
So we're talking about high pressure, kind of medium intermediate pressure lines. We're not talking about the low pressure that's down at millibars where you could have kind of non-welded lines. These are all fully welded steel lines in most cases, some PE lines. There is a chance where we have lines where we haven't got the records, and we're kind of concerned about the metallurgy, so we don't know about the kind of condition of welds. In those cases, lining them to keep the hydrogen away from the steel, so that we've got the assurance. Not there's a problem, but we just can't demonstrate it. So we might then line or spray up to keep the hydrogen away. But fundamentally, there's no reason why we can't repurpose. And obviously, a massive cost saving for the UK if we can use those lines and we don't have to kind of decommission them ultimately.
Have you demonstrated that those lines are methane's quite different to hydrogen?
Yes, so there's a lot of testing going on at Spade Adam. So there's projects at National Gas are in for the high pressure ones. There's ones at SGN, Southern Gas Networks, are using on the kind of medium pressure. We've been doing ones on lower pressure, where we've been cycling kind of the lines with, I think, the challenge comes actually with the newer lines. So when you've got the brand lines that have been put in the last few years, where you've got high tensile steel, and fixating and things like that, you can get hydrogen embrittlement. It seems to be a lot less of a problem than was first envisaged in that, and that's where they might have to do some lining or something with those new lines. But the ones we're using are the ones that are mild steel that don't have those challenges.
Do you want to say anything about what needs to be done to test these lines? Hang on, you've got to speak to the microphone apparently.
Yeah, and hold it fairly close, please.
Singing's not really an option.
No, I can't.
Telling jokes, that's fine.
Okay. So from my perspective as a safety engineer, hydrogen is going to leak at some point unless it's fully welded line, and then you may have some sort of travel of hydrogen through the material itself. I think these things are quite well understood. So for me, it's a pressure testing thing. What pressure you're going to run it at, and it's the existing pilot line still understanding pressure from a different substance.
Does anybody else want to say? Do you want to say anything about that?
Yes, so we have an option of reusing some existing pipelines within the region that's already there. We have it as an option, but it's not the base case, because the amount of work to validate, test and expose them, it's something we're exploring. It'd be great if we can, but the assumption is we will be, potentially installing new pipe work, but we will reuse if we can.
Just a quick supplementary. Yeah. That's a huge volume difference in the amount of energy. You need to move about 4 times as much hydrogen to get the same amount of energy as you've got from natural gas.
That's
You're going to be able to do that.
That's in the volume pipes. It's a different fluid, so it's much less viscous, and it will actually move quicker in the lines, so we don't get the same erosion that we do with methane. And it's actually being worked out. I mean, the initial what we're doing in Australia on this, there's been work done to look at the velocity that we can translate at.
Right.
It will be a high velocity.
Yeah.
And so for the same amount of pipeline and the pressure regime, you only get about 15% reduction in the amount of energy moved with the same pipeline, because you're moving it at a high velocity.
Nice speed. Brill, thank you. You had your hand up next.
Yes, please. Hiya, can you hear me? So my name is Verity. Casey. I cover science for North East Bylines. I've got a couple of questions, so you need to stop me if I'm taking up too much
You've
time.
asked one,
Okay, then.
and then
I'll
if everyone else has run out
okay.
of questions,
I
we'll
will.
come back
I
to the
need to
second
come
one.
back to, yeah. My question really is about the pipeline network that will connect H2 North East, the Kellas terminal, with Wilton. Looking at the map there, it looks like it might be heading towards the cracker, the ethylene cracker. Does that sound about right? Anyway, to plant on the far side of Wilton. Now, that will use what's called the utilities corridor. You'll be familiar with that. That was built when Hichem Phillips built their refineries at Seal Sands in the late 1960s. That part of it. So, but other parts of it were built. The ones in Wilton, it was built earlier than that. They were built in 1949. We connect Wilton with William to Hichem plants. So the utility corridor, which I'll get the point in a minute. Utility corridor is quite old, and also you're going to be transporting hydrogen by it. That corridor also transports oxygen, I believe, nitrogen, CO2, to name but a few. And I would just have concerns about that. I was wondering if you could address my concerns.
Yeah, it's a good question, but don't forget we've historically transported hydrogen around the region. So we have BOC produced hydrogen North East transported to Wilton. The old Thames gas had a high proportion of hydrogen. So hydrogen isn't anything particularly new. We just need to make sure that we know and manage the risks. So when I mentioned earlier, we are looking at existing pipework. Our presumption is we will be installing new pipework in that area. We have a tunnel under the river, which we'll be using.
True.
But no, we have our own, not to be all thinking of.
All right.
Yeah. I think that the other key thing which people forget, including me, is hydrogen is a really small and light molecule, so it dissipates quite quickly. So whereas with a lot of natural gas, for example, you're worried about it sinking and collecting down, here with hydrogen it'll go upwards, so you might need to change some of your sensor locations and some of your precautions. But it's making sure that we do that thoroughly. And Nick has done a lot of work over the years about hydrogen and other gases and how to safely manage them.
Don't forget that the old ICI system had 2 hydrogen mains in it as well that were different pressures and different qualities. So that 2 of the salt caverns, I don't know if they still are, because Savic own the system now, but it used to be rated for hydrogen storage, and they could store 40,000 tonnes of hydrogen. So there's an awful lot of hydrogen infrastructure around Teesside that's been there for a long, long time.
Yes. Just quickly, where are the salt caverns? I don't know where they are.
Six sands.
Oh, right.
Gentleman was asking where the salt caverns were for the people online.
Any next question? Gentleman in the middle.
Just
Oh,
wait
hang
for the
on, we've got to have a
microphone, please.
Darren.
Hello, can you hear me? First gentleman who spoke. Could you tell
Hold
me
it
about-
nearer. Hold it nearer.
Could you tell me about
That's it.
the carbon capture system and how much energy it consumes of the total energy you're generating? Thanks. A simple answer to that one is I can't. I'm not really involved in that. But we have, we have specified what we believe is the world's leading technology, both in terms of carbon capture rate, but also in the efficiency in it as well. Is it an established process? It is used on a lot of projects which are either in operation for other uses or being considered for hydrogen production direct. So there's a lot of technology around capturing CO2 from gas. I mean, CF have done it for years to separate the CO2 from the hydrogen and the ammonia. So there's a lot of technology there, but really this is about trying to get it so it is efficient enough to meet very close as we can to the price of natural gas, because that's the challenge we face. How do we do this so we can decarbonise and the customers aren't going to be priced out of business? So it's there is no silver bullet for this. It's a tool, but it's all about reducing the costs and doing it safely to give the customers an option.
Thank you.
How's the CO2 going to, where's it going to? And how are you going to keep it there when it's got there?
So my answer is the easy one. It's going to go to the
Somebody else, yeah, all right.
But essentially, there's a CO2 collection network being built by NZT, Northern Endurance Partnership, which will collect CO2 from a number of emitters. It will then be compressed, and then it'll go offshore. I think it's basically opposite Thumber Head, and be stored under there. And that is a separate entity. So essentially they're providing a service to a number of emitters in the region. And indeed, a lot of our customers we're talking to have done the comparison between installing carbon capture themselves or essentially was providing decentralised carbon capture and giving them a decarbonised fuel.
Lovely. Do you want to say anything about this, Hichem?
Sure, yes. So I think, as they mentioned, there are a lot of technologies around the carbon capture. It's quite mature as well technology. So of course, MEA based carbon capture. But so Porjects, for instance, which is one of them. Shell, they have also quite a promising technology on blue hydrogen. So where basically they capture CO2 at high or mid pressure, which reduce basically the cost of recompressing the CO2, which go to the sequestration. So in terms of the role of RTU, I think that's also play quite an important role here. Just giving an example of we recently applied for Horizon Europe project on the development of a better carbon capture technology, where the cost will be definitely a target to reduce it. And that's also an ongoing or in parallel as well, or in terms of initiative to try to reduce or tackle the cost through research and development, while basically having the best technology or available technology that we can use. So so there are definitely a lot of options. And research on technologies are there also active in terms of carbon capture, which is a key technology for transition, sustainable transition.
Over at the front.
Yeah, just a moment while we get a microphone there. Yes, it is. Hold it close.
What pressure and temperature are the carbon dioxide stored at? If you tell me. Because if it's below 35 degrees centigrade, which is the critical temperature of carbon dioxide, it may be possible to store it as a liquid.
I can't answer the question about storage, but there is 2 different networks being proposed. So there's a pipeline coming to Teesside, which will operate at a lower pressure and in the gaseous phase and be and stored. And the pipeline to Humberside is operating at a higher pressure. So that is obviously going to have more compression costs into that side of it. But in terms of the storage details, I don't know that is a third party project.
Alan next.
Quick enough.
Okay, I've got a very impertinent question. I'd like.
Are you addressing it to Alan? Everybody.
Oh, everybody, yes. Ideally, what I'd like from each of you is an adjective, and I'm going to start you off with an adjective. A couple of weeks ago, I was talking to a couple of ladies from one of the leading developers of systems for hydrogen reduction of iron ore for steel, which all the UK steel industries need. None of them are proposing to put in their own plant because they all think that hydrogen can't possibly be cheap enough. These ladies were working for an organisation that would love to flog plants for hydrogen reduction. Alternatively, they can sell hydrogen, which they would make in Scandinavia. When I asked these ladies, or the chief of the 2 of them, about what they thought about the prospects of sales into the UK of their sort of kit, when thinking about the prospective price of UK hydrogen, the adjective she used was hilarious. What adjective would each of you say?
For what? For the chances of the hydrogen economy happening?
For the prospects of getting the hydrogen price down sufficiently low that the uptake in bulk UK industry is not going to regard it as being hilarious.
Impossible.
I'll use the word challenging, because I think there's some industries where it is the lowest cost and one of the lower cost options. If we are going to decarbonise and keep industry operating, that's a prerequisite for doing something. Blue hydrogen is lower cost than green. It's not perfect in terms of it uses natural gas, so it isn't zero, but it's closer to zero than we currently are. Some industries, it just will not make sense to use hydrogen. That's why I say it's no silver bullet. They're looking at electrification or biomass or other technologies.
I think I used the word already in my introduction, and that's exciting because I think it is changing so fast, and I don't think anybody in this room knows the answer. But you've just got to look at what happened with things like wind, where everybody was saying poo-poo wind, and now it's the cheapest form. The drivers for kind of hydrogen coming down will be different, and we probably don't all know what those are going to be. But we've got to get hydrogen produced at scale. We've got to move it forward, otherwise it won't happen. And I think here in the northeast it's happening. As we kind of expand renewable energy capability in the UK in terms of wind and solar, if we do that to the level we need to supply kind of industry, transport, kind of homes, everything, then 90% of the time we're going to have far too much. We're already paying billions to the kind of producers of wind power. for them to do nothing. So if we can make the right kind of regulatory regime and the right tax regime to support the growth of hydrogen, the whole system approach is going to drive that cost down, and hydrogen is going to play a huge part in this for a whole number of reasons. Cost being obviously one, but the ability to store and things like that. So you're not just comparing the cost of production of hydrogen costing, you're comparing the cost of storing energy, for example, and this is the best way. But I think it's just fascinating and exciting is what's going to happen over the next few years.
I will answer this one, but I'll go last.
Oh, thanks for it's a really interesting kind of observation. So how to start with I think just for the objective, I would say it's a slow, but we will get there eventually. The UK has a lot of great ingredients already here. So we have a really good alternative or renewable energies. So wind is part of it, one of the best in Europe, for instance. We have also the willingness for the government, the recent one, which is the having this strategy, industrial strategy, which become independent from any new governments. That's basically a kind of a step toward having the people who are dealing with the technical or the companies who dictate or provide the direction of those technologies. There are a lot of also good promising technologies that will eventually reduce the cost of electrolyzers. So the electrolyzers, there is the alkaline, PEM, and oxide base and others. So there are a lot of activities in terms of trying to remove the rare earth materials, which are making the highest cost of the electrolyzers. So I think it's going in the right direction. 2024 wasn't great. When we see it globally, there was a lot of kind of slowdown in terms of the projects worldwide, and that's mainly was due to the a lot of elections as well that slowed down and made a lot of uncertainties. But I think in the UK, from what I can see, is that we are going in the right direction, and I think so we need to be also realistic in terms of the hydrogen. Hydrogen won't solve everything. It will be used for for instance, high temperature processes, or as a buffer for making more resilient in terms of the energy. So my prognostic will be that mid of 2030s we will see quite a drastic change in terms of the price, and which will start competing with the blue hydrogen. But yeah, that's my own prediction.
Thank you. So from my perspective, I think the adjective I would use is interesting. And the reason why is whatever you do, you need to understand your hazards. What can go wrong? How bad will it be if it goes wrong? How we do it? When you are trying to achieve a low price, then perhaps that will introduce new technologies that we don't already have, and that makes my job interesting, because when you introduce new technology, you need to really look into it quite a lot deeper than with existing technologies to understand what can go wrong. So it's, quite an interesting thing from a safety engineer's point of view. I love all this. That's learning new things and looking at new technologies that are novel that I've perhaps never seen before, and helping people to study this and understand what the hazards are. So from that perspective, it's interesting. From a safety engineering perspective, from me overall, I would say it's important. Doesn't matter to me what the price is. The point is if you want to use it, you need to do a hazard study. Let me do it.
So I'm going to use my chair's prerogative to answer this. I think possibly, and I think there's a few reasons for that. I think the fundamental challenge is that to make a kilo of hydrogen, you need quite a lot of energy, and there's about 33 kilowatt hours of energy in a kilowatt of hydrogen. And at the moment, you can't make one for less than 60 kilowatt hours. So that means you've got to almost double your energy requirement to make the hydrogen. Using it, looking at it the way we look at it at the moment. I think the second problem is our climate doesn't help. In the summer, we've got way too much renewable energy. In the winter, we haven't got any to speak of. And then, I don't know if you looked at the stats, but in January, we were pretty much 50% dependent on gas to make our electricity. So we're many, many years away from having enough energy to be able to make the volumes of hydrogen we want. But on the positive side, when I was doing a bit of research for this, I came across a company called Volta Hydrogen, who have a pyrolysis process that takes, you move natural gas to the point of use of your hydrogen, you pyrolyze your natural gas into hydrogen and solid carbon, which is graphitic almost, by the look of it, according to this company. So you'd be changing the economics, because you wouldn't need to invest in distribution and what have you. So I think people will, a bit like the Chinese AI thing, people will come up with solutions that will make things change. How quickly and how effective, I think it's difficult to know.
I'd like to invite questions from those online, please. If you could click the little button at the bottom with a hand. If you'd like to ask a question online, click the little hand at the bottom and we'll come to you. Okay, in the meantime, we'll take a question from the back.
No. Next hand was over here. That guy there, yeah. And then those two were after him.
Sorry, I was looking at the screen for a forest of little hands appearing, but
There aren't any.
Okay, so my question is actually about skills, and I understand about the opportunities that the hydrogen economy will bring to the Tees Valley region, and what resources we have currently in the region, and where the gaps are, and how, if any thoughts or plans being put in place on how to address that, so that we bring everybody on this journey in the Tees Valley region all benefit from this new exciting economy.
I'm going to give the mic to Hichem first here, and we'll go this way around.
So just to formulate, so it would be the gap around the region for enabling hydrogen economy.
The skills.
Yeah.
It's the resources, the people actually for the jobs and roles that are going to be needed.
Yeah, that's really important point, Simon. So we need to start basically training people to make sure that the skill set evolve and respond to the need. And at the moment, from what we can see in terms of the curriculum, and we are slightly behind actually the curve. So putting an accent, important accent on the training, and also the upskilling of the workforce, the key basically enabler to make this the and help to have this. I mean the evolving technology with the people who can basically adopt it. And one thing as well is that starting as early as possible from schools rather than from so having or providing the awareness from childhood about where we are going, because there is a shift globally. There is an economic shift here, where previously the companies were looking for mainly profit, but now basically we have a new dimension which is requiring ESG, for instance. So how basically they can make a profit while looking after the environment and looking after the sustainability. And that's need a real shift and rethink of the how we can train the next generation.
So speaking from a perspective of hydrogen safety, which is quite a specialist subject, personally I did a course with Ulster University, which was 2 modules of a master's degree in hydrogen safety, and it was specific to that. So I'm spreading the net a bit wider to process safety and safety engineering. I think you need to have 10 to 15 years minimum experience as an engineer, and certainly at least 5 to 10 working in safety engineering, looking at hazard studies, the SEER assessments, things like that. It's not something you can train quickly. There is knowledge out there, but you know, I recruit safety engineers, and trying to get them is like pulling teeth. They are really difficult to get, and good ones are really difficult to get. Do we really need that en masse? No, not really. There's plenty of standards out there for design that you can go to, like you said before. Hydrogen's not a new substance that the industry is using, so there's plenty of knowledge out there. It's making sure that the designers of the systems that use this, create it, convey it, that they're aware of these standards, and they're given the time during the design process to apply the properly.
I think I'm going to give an answer in 2 parts. I think the good news is that a lot of the skills and the experience we already have in the process sector, in the chemical sector, in the steel sector, in the oil and gas sector, are directly applicable. Yes, there'll be some refinement of some of those skills, but the core skills are the same. The downside, we're struggling to get people into those professions. We're struggling for the numbers now. So I think it's really a case of, you know, doing what we've been trying to do, get people to explore STEM careers and want to go in to be an engineer. But that's hard.
Yeah, from my perspective, it's a massive challenge. So on the negative side, the kind of first sort of carbon capture pipeline is just about to be awarded by Eni across on the HyNet project, and the guy that's running that team used to work for me many years ago, and the whole team virtually is the team we had in 2005. It's like a Dad's Army reunion. There's quite a few who should have really been retired and have been retired. But on the other side, I've seen it where whenever there's a demand and there's interesting and well-paid work, people will come, they will get trained, and we'll build on the resources that we've got. I mean, the whole kind of industry is changing. We didn't have people putting mobile phone networks up 30 years ago, but that network got put up and installed, and there's a whole team of people experienced and skilled in doing that. So it will change, and those resources are kind of will come, but there will need to be investment and effort to make sure we do that. And there's going to be a bit of pain initially as we start these first major projects off, but I'm confident that we will evolve, and people, and also, what are all these people going to do that are going to be put out of jobs by artificial intelligence? This is going to better give us some opportunities, because there is going to be kind of changes in a lot of industries, and there will be people that are looking for new careers.
What is it?
Okay, Brad. Okay, yes. So hi, I'm Mike. I'm from Redcast. I was on the edge of the H2 carbon capture project. Sorry, on the distribution project, domestic project. Go ahead. I also attended a jamboree at Redcar College about a month ago, and they were talking there about, oh yeah, we're going to have all these wonderful jobs for people. I've recruited 14 engineers this year, all kids. Okay, nothing for people like us, nothing for the old guard, nothing for the people that they just weren't interested. There wasn't time to do the apprenticeships. They didn't really care about that. Yeah, if you're from the steelworks from ICI, some of you are too old, basically. Or at least that was the attitude. There was a little sort of thing at the top there about, yeah, we care about adults, but really, it was kind of really didn't gel well with the audience. That was more this sort of demographic, like that. Anyway, my question was also a bit of a.
I was going to say, is that a question? Or...
It's not methane the same, because not oil, or oil's the same.
Is all methane the same?
Yeah, in other words, talk about natural gas, you don't actually talk about methane, or because of multiple things.
No, it's not when we bring it from the ground. The methane is methane, but the way it's extracted, the way it's processed, the way it's transported results in massive changes in the carbon intensity. So if we're bringing gas from America, there's compression, there's transportation, there's regasification costs involved in that, and all of that takes energy and produces carbon. So the gas may be the same, but getting it from A to B, from the well to the user, can have different impacts on the carbon intensity. So we are pretty well regulated in this country in terms of methane emissions. We are lucky in that we have gas near us. We have a bit of a education exercise ongoing, trying to educate certain politicians around, all gas isn't the same. So if we're bringing gas from America, we're bringing gas from Russia, if that comes back in, then not only is the carbon intensity going up, but we're losing the economic benefits of that. And I think I just question, not what you've said there, but I question why people don't want to employ people with experience. We need people. There are people here in this room with a lot of experience, and the key is recruiting a mixture so that experience gets passed on to apprentices. It's not something which is going to happen overnight. You certainly don't become a hydrogen aficionado or a hydrogen safety expert. You need contact with that knowledge and experience.
Oh, I was just going to add, there's a few of us sitting in this room who have been trying to retire for a long time and have failed so far because people keep asking us to do stuff. So not all other people are without a job. There was one other hand that put the back.
Yes.
And so I'll take that one and then this one and then we'll finish.
Yeah, thanks so much for the presentations. Just on public perceptions, based on what you've mentioned, right? Just recently, we all know that has to be screened off, mainly because people weren't so happy about it. How far off are we with regards to, getting, because we can have all these wonderful technologies, but if people aren't so keen to accept it, then we have quite a lot of challenge. So are we in the right direction? What has to change for people to accept these kind of wonderful technologies?
Maybe I can answer that one, because obviously from Northern Gas Networks, that was the Red Cap project was a Northern Gas Networks project. And I think what's happening, we did a big study afterwards to understand what people's thoughts were and reasons. Fundamentally, the kind of key came out of that is people don't want change. It wasn't that they were kind of anti-hydrogen or something. They just didn't want kind of their houses messed around with, and there was also unknowns, so they didn't understand about the safety and things like that. And so it will take a long time for kind of the general public on a domestic level to kind of understand the next step to kind of hydrogen, to say they just don't want anything but heat pumps or hydrogen or whatever. On the industrial scale, it's completely different. There's huge support. Every kind of company we go to, they're saying if we can get hydrogen to us and it's at the right price, we're really interested because it supports our business. We want the high temperature, we want the volume well, other things like we don't need to change all our plants as much as we would do with other solutions. So there is a challenge with public perception, but I think there's a challenge with public perception about anything that involves significant kind of significant change and going into the unknown. And so I think it will evolve over time.
Yeah, we're also not very good at remembering. Again, this is an old person thing. But town gas, which was made from coal, was 60% hydrogen. So we've actually had not far off hydrogen economy already once upon a time. It's just we stopped it. So yeah, our perceptions are weird, aren't they? I'll just take this one thing. Yeah,
we're doing one study on international evidence. So one of the things government said when they're not going to do red car. They were going to get evidence from outside the UK, so they're going to use the project in Scotland and then look at what's happening elsewhere. And we've been on a trip to Germany and Netherlands, and it's just a completely different atmosphere there.
They don't have all this anti about everything there. They're generally supporting, they're looking at the science, they look at the details, considering things, just a completely different atmosphere in the kind of Germany and Holland as the places that we've been to.
Before you do go to Peter, we've got one question online. Keith Lewis is asking, how can we use AI and IT tools to accelerate the skills and experience transfer and use to the next generation that will need to design, build and operate these high-tech hydrogen facilities? Is that a reasonable reading of your question, Keith? You can unmute yourself if you wish. And
yeah, that's fine. I just feel like we're in this paradigm that everybody needs 10 to 15 years experience in order to be able to contribute. And how do we get that experience timeline down and get people interested in this development? As you say, I was in the Netherlands for 15 years. It was a completely different mindset over there.
Hichem's young and we're all old, so I'll give it to him to answer the.
That's actually one. So yeah, I think that the AI is a fantastic tool. So yeah, it's accelerated a lot of things. For instance, the learning. For instance, if we want, for instance, to go for a paper, to read the paper quickly, we can submit it and ask for having a summary, and quickly within 2 minutes it will provide you the conclusions. So it's a companion tool, but it won't substitute the learning between generation. And going back to the gentleman there, having a mix of experienced people working alongside with the new generation is a must, and we need really to make sure that we have this create this environment where the new generation work alongside with the more mature people to get the sense, because a lot of things cannot be unfortunately taught, and it needs to be transferred by basically working and collaborating. So yeah, just a summary to summarize, AI is a really great tool, but yeah, we need still to have unfortunately people to, or likely for to have people basically to coach as much as possible with the new generations.
Right, this really is the last question.
Peter over there.
The man with his hand up.
The oldie in the corner.
Yeah, I'm going to ask a very open question. How long would it take for hydrogen to be a viable fuel for domestic users, or will it ever be? Not just thinking about the cost of hydrogen versus the cost of natural gas, but the practicality. I was involved in 1970 in the conversion from coal gas to natural gas, 2.5 years, in which case, with contractors required all over the place, millions, if not billions of pounds were spent. Net result is we're now thinking of changing again? I don't think so.
Yeah, maybe lead on that one. Well, if you go to Singapore and Hong Kong, they're still using hydrogen in the form of the land that's in the town gas that we use there, so it hasn't gone away. If we're going to meet net zero, we can't keep doing what we're doing. So we can't just keep pumping methane into people's houses, as we will never achieve net zero. So we've got to do something different. And whether that's heat pumps or hydrogen or heat networks, I think it will be a combination of all of those. I don't think the government's going to push kind of hydrogen for domestic, because I think there's more important things to use hydrogen for at the moment. So whether that's transport, whether it's for power, heart of industry, storage. So I think that's where the focus will be for hydrogen. But I think in the areas where the hydrogen economy does grow and take hold, and that's particularly around this area, then I think that it makes sense in some cases to start looking at kind of using hydrogen for heating. As I said, there's places on the continent where it is actually being done in small numbers now. So I don't think it's a kind of technical or fundamental safety problem. We have to make sure we can put all the process in place. So it will happen, but very slowly, and I don't know when. I think the focus will be on industry and power for the foreseeable future.
That seems like quite a good place to finish, actually. So, I did say that was the last one, I'm afraid. Sorry. You come talk to us afterwards.
We'll answer it.
So, thanks very much for your questions. Thanks very much for listening. And please join me in saying thank you. It's been a great time.
I'd just like to say a few words, please, and especially thanks to Graham for keeping them all in order. Thank you, Graham. If you haven't signed one of these signing in sheets, will you please come down to the front and do so, so that we can get a record of who was here. Our next event is on Wednesday, March the 5th. That will be over at Middlesbrough College, the Young Persons Lecture Competition, and a guest lecture on small nuclear reactors. So I think with that, I will say thank you to one and all, and thank you to those who are online.